All right, guys, operations of radicals part 2. So I'm going to actually back this up a second and show you the answers to last night's homework. All right, go ahead and pause on this page so you guys have a few moments to look at it. I do have all my work showing for you, and hopefully you guys can figure it out. Talk it out as a group if you need to, so that you guys can, you know, figure out how I got my answers. And then here's the next page. Again, pause the video if you need to so that you guys can figure it out. I did color code my foiling so that you can see where my numbers are coming from. Again, pause it and wait until everybody can figure it out. I'm going to scroll so you guys can see the very bottom, and you can see number 46. Again, take a moment. Okay, so I'm now going to start our lesson. Take a couple minutes, maybe 2 or 3, not anything terribly long, and go ahead and work on these problems, simplify these. They, of course, are going to get a little more difficult as we go along. So again, take 2 to 3 minutes and work on these. Okay, so I'm going to start going over the answers. This first one, this becomes the square root of 36 times the square root of 3, or 6 root 3. Okay. 112 actually can become negative, and then the square root of 16 times 7. I know that one's pretty tough. Negative 4 root 7. 140,000, right? That's going to become the square root of 10,000 times the square root of 14. And the square root of 10,000 is 100, and then times the square root of 14. Next, we can just add those. So 10 root 3, that one should have been pretty straightforward for you guys. All right, now we got this big long string of things that we can add. I'm going to put the things that look alike together. So 5 root 7 minus 8 root 7 plus 2 root 7. And then I'm going to have what? Plus 3 root 17 plus 6 root 17. Okay, and so when I put all of my root 7s together, I end up with negative square root 7. And when I put my square root of 17s together, I get 9 square roots of 17. And then the last one here, I'm going to multiply 3 times 4 and I get 12. And then I'm actually going to multiply 14 times 21 and get the square root of 294. And you're like, what makes the square root of 294? And I'm sure it was extremely obvious to you. I kid. It's 49 times 6. And so this is 12 times 7 times the square root of 6. Okay, and we end up with 84 square root 6. Or you could have done 12 and then had the square root of 14. Let's change that. The square root of 14 would become what? The square root of 7 times the square root of 2. And the square root of 21 would be the square root of 7 times the square root of 3. And that becomes 12. And the square root of 7 times the square root of 7 is just that, 7. And the square root of 2 times the square root of 3 is the square root of 6. And you can get there just a smidge faster. There are multiple ways of getting that, and that is just one of them that I came up with. All right, let's go to the next page, shall we? All right, so we're just going to continue with working with our different operations. Remember that you must have the same radical as you are going through these, okay? We must have the same radical as we're going through these. And so these don't all have the same radical, so I'm going to try to get them to either become all 8s or all 5s. And of course, we do want to simplify this as far down as we can as well. So the square root of 20, right? The square root of 20 is what? The square root of 4 times the square root of 5, also known as 2 square roots of 5. So there's where I'm going to get that one. The square root of 8, if you have not started to memorize this one, you're going to see it a ton between now and when you guys graduate high school. The square root of 8 becomes the square root of 4 times the square root of 2, which is 2 root 2. Like that's just one, kind of like knowing, 12 squared is 144. Like just one of those ones that you just start to kind of just know. All right. So plus 2 root 2. And then we have the square root of 5. Can't do anything with that other than combine it with this one here. So I end up with 3 square roots of 5 plus 2 square roots of 2, and I cannot simplify it. Okay? Now this next one gets really messy. If you need to, pause the video as I go through it and try to figure out where I'm coming up with my answers. So I'm going to come off to the side. The square root of 27 is the square root of 9 times the square root of 3. Also known as 3 root 3. Again, one of those ones you're going to see a ton of. So this becomes 5 times 3 root 3. All right. Now we've got this 6 root 8, right? So the square root of 8, I just told you guys from up above, is 2 root 2. So we have plus 6 times 2 root 2. Now we've got minus 2, and then I've got the square root of 75. The square root of 75 is the square root of 25 times the square root of 3, or 5 root 3. So minus 2 times 5 root 3. And then lastly, I've got the square root of 72, which I know becomes the square root of 36 times the square root of 2, or 6 root 2. But we have a 4 in front of there, so 4 times 6 root 2. Okay, so I can simplify this into 15 root 3 plus 12 root 2 minus 10 root 3 plus 24 root 2. I can combine the root 3's and the root 2's. Okay, so I'll go a little slow. 15 root 3 minus 10 root 3, right? I can put those together, plus 12 root 2 plus the 24 root 2, right? Put the ones that look alike together. And so when I have 15 root 3 minus 10 root 3, I end up with 5 root 3. And then over here, I should end up with what? Plus, did I make a mistake somewhere? I think that ends up being 36 root 2. Did I do that right? I think so. Man, I completely forgot the 3 root 50. Okay, let's deal with that a minute. Let's throw that in there. 3 root 50. We'll just toss that in there. The square root of 50 is the square root of 25 times the square root of 2. Oh, we're all good. And so we've got what? 5 root 2. And so I've got minus 3 times 5, which would be 15. I'm going to toss that in there. Minus 15 root 2. So my grand final answer, sorry about that, you guys, is 5 root 3, plus 21 root 2. There we go. I found it. Yay. Sorry. I know you guys probably all panicked earlier. I did get it. I finally caught my mistake. There we go. Phew. Okay. Next, we're just going to distribute. Just distribute. 3 times 15. Now we could do this a couple different ways. Okay. Let's multiply. 3 times 15. 3 times 15 is 45. Plus 3 times 21 is 63. Right? So the square root of 45 plus the square root of 63. The square root of 45, right? That's the same as 9 times 5, right? The square root of 9 times the square root of 5. So 3 root 5. So that becomes 3 root 5. And then the square root of 63, that's the same as the square root of 9 times the square root of 7, or 3 root 7. And I cannot combine those. So that's my final answer. That's not terrible. Now, this next one, you'll notice that they all have multiples of 7 in them. So it might be helpful to us to kind of deal with that. Let's see here, 21, right? 21 times 35. So let's see here. 21 is the square root of 3 times the square root of 7. And 35, right? 35 is the square root of 7 times the square root of 5. Okay? And then let's do the square root of 21, which again, I'm going to tell you is the square root of 3 times the square root of 7. And the square root of 77 is the square root of 7 times the square root of 11. Woo. And why in the world would I do that? So that these two here will combine, and these two here will combine. So in my first one, I end up with 7 times the square root of 15, because 3 times 5 is 15. And in the second one, I end up with, there's a plus here, plus 7, and then 3 times 11 is the square root of 33. And we're done. Now you could multiply 21 times 35 and 21 times 77 and get these huge, massive numbers and then try to figure out how to rationalize them. This way was way easier. Trust me, I've done it both ways. Okay, we've got a fraction. My first instinct, usually to look at fractions, is to try to reduce. All right, what goes into both 75 and 125? And I know that 25 goes into both of those, right? 25 goes into both of those. So this becomes the square root of 3, right? And this becomes the square root of 5. And so I can't have that though. That's illegal. So I'm going to multiply both the top and the bottom by the square root of 5. So I end up with the square root of 15 over 5 final answer. What? Way to go, Mrs. Hoekstra. All righty, here we go. Next one. What goes into both 27 and 297? Actually, believe it or not, they're both divisible by 27. Okay, so I'm going to divide both the top and bottom. I'm going to reduce this whole fraction. Think of it as one big fraction, 27 over 297. Okay, and 27 goes into itself once, and 27 goes into 297 11 times. Now, this is illegal. I cannot have a radical in the denominator. So I'm going to rationalize it by square rooting both the numerator and the denominator by the square root of 11. And I end up with the square root of 11 over 11. Yay! Last one on this page, I believe, way down here. How in the world would you reduce this one? I like to see it as 6, right? Negative square root of 6 over 30 and reducing that. So this becomes negative square root of 1 over 5 or negative 1 over the square root of 5, but that's illegal. The square root of 5 over the square root of 5 will rationalize it so that I can have a correct legal answer, and I have negative square root of 5 all over 5. Take a pause, wait, discuss, figure out what in the world I did and compare it to what you guys have. All right, let's distribute. Now, we would have called this a difference of 2 squares. We would have called this a difference of squares. That's what it kind of looks like from, 2 chapters ago. So here we go. What's the square root of 5 times the square root of 5? Right? That's going to give me just plain old everyday 5. I'm going to do this in colors so you guys can keep track of where I'm going. The square root of 5 times negative 3 is negative 3 square roots of 5. Okay. Then I'm going to multiply 3 times the square root of 5, and I have plus 3 square roots of 5. And then lastly, I have positive 3 times negative 3, which gives me negative 9. And you will notice that my middle 2 terms are opposites. They're going to cancel each other out. And so I really end up with 5 minus 9, also known as negative 4. Okay, so it actually cleans up. When you get a problem that looks like that, it's going to clean up very nicely. Okay, promise. All right, let's take a look at this next one. This is 7 plus the square root of 8 quantity squared, which means I actually have this written out twice. That means 7 plus the square root of 8 times 7 plus the square root of 8. That's what that means. So again, let's go through step by step. 7 times 7 is 49. 7 times the square root of 8 is 7 square roots of 8. I have a second one of those, 7 square roots of 8. And the square root of 8 times the square root of 8 is just that, 8. My middle two terms can get combined, and my outer two terms can get combined. So 49 plus 8 is 57. And then 7 root 8 plus 7 root 8 is 14 root 8. Again, pause if you need to, so that you guys can figure this out. All right, moving on. I'm going to distribute 3 root 4 times 2 root 3. 3 times 2 is 6. The square root of 4 times the square root of, well, you know what? I'm going to change that. Scratch that. What's 3 times the square root of 4? This is really 6 times 2 root 3 minus 6 root 32. Let's just make life easier on us, right? All right, here we go. 6 times 2 root 3 is 12 root 3. And 6 times negative 6 times the square root of 32 is negative 36 times the square root of 32. Square root of 32, right? What makes the square root of 32? Square root of 16 times the square root of 2, or 4 root 2. So let's see here, we've got 12 root 3 minus 36 times 4 root 2. 36 times 4. 36 times 4 is 144. All right. I can't combine those because they don't have the same radical, so I'm done. Okay? All right, let's try multiplying these last two down here at the bottom of the page. This one's actually pretty straightforward. I'm actually going to multiply this out. I'm not going to simplify first. So 30 times 10 is 300. So I've got the square root of 300. And then x cubed, excuse me, x to the 5th times x becomes x to the 6th. And I like when I have an even as my exponent. Now the square root of 300, right? The square root of 300 is the same as the square root of 100 times the square root of 3, right? And then x to the 6th, I can take the square root of that. So this becomes 10, the square root of x to the 6th. Remember, you just cut it in half. So x to the 3rd, and then square root 3. Okay, last one. 90y times 40y to the 3rd. Actually multiply it out. So 9 times 4 is 36. Add my 2 zeros. Y to the 1st times y to the 3rd is y to the 4th. You're just going to add those. Well, what makes 36? Well, that would be 6. But this is actually a perfect square. This whole thing, I should say, is a perfect square. So the square root of 3600 is 60, and the square root of y to the 4th, just cut it in half, is y squared. Piece of cake. Piece of cake. There you go. You guys are going to do the worksheet on the next 2 pages. Have a good one.